So we're all
I
set
think you
up
can
to
go ahead.
start.
Good to go.
All right, great. Thank you. Well, good morning, everyone. Really delighted to speak to you this morning. Unfortunately, cannot be there in person, but I'm sure by now we can make this work in this very nice virtual and physical setup. So we'll actually I'll be taking the conversation from what we just discussed, a very concrete case study to a bit of a more broader discussion, a forward-looking discussion on actually what the role is of industrials to really achieve the climate targets of 2030, really with a focus on the coming decades, and actually also stepping a bit beyond, let's say, the core topic of ener.CON, and look at really the full mix of solutions and technologies that industrials will need to adopt to make sure that we get there by 2030 and eventually by 2050. So indeed, our topic of today is centered on green thermal and clean molecules. And so what I'll do with you in the next 25 minutes is give you some general recommendations for you as industrial players, how you could best prepare to capture the opportunities in the coming decades and make sure you're well on track on your decarbonization and emission reduction pathways. Paul, thank you for the intro. So maybe just a very quick word. I'm part of Engie Impact. Engie Impact is a new global organization within the Engie Group, an independent global team focused on sustainability transformation. That means for us that we're stepping beyond our traditional energy disciplines and competency. We take a full perspective on emission reductions. And next to that, we also help on waste and water management. And we do that also as well with a broader transformation outlook. So not just looking at single sites, but looking at full value chains, covering all of the emissions from scope 1 to scope 2. All right, let's get started. So if you just look at the role of industrials in moving to climate neutrality, then actually in Europe, what we've seen is that the past decades have not been too bad in terms of initial performance. The EU has hit its 2020 greenhouse gas reduction targets. But we're now obviously in a time where the ambition for 2030 is being revised. The Commission, I think 2 weeks ago, has confirmed that they actually want to set 55% greenhouse gas reduction targets by 2030. It looks like that the European Parliament will probably follow that because most of the major factions are as well ranging between 55% and 65%. So it's clear that the coming 10 years will be instrumental in getting us on the path to climate neutrality by 2050. But if we see at the recipes that brought us here today, I think a lot of good things have happened in industry on energy efficiency. There has been a first wave on a shift to green electricity supply and generation on site. But unfortunately as well, and we have to admit, over the past 30 years, there's also been a substantial deal of offshoring carbon-intensive industries to other regions of the world, and that also has partly contributed to where we stand today. And so it's clear that the recipes of the past will probably not bring us to the target of 2030. And you see here an estimate by Bloomberg New Energy Finance, but you also see on the right a graph from the International Energy Agency that basically shows that for industry overall, if we take current measures, current technologies, if we take the nationally determined contributions of the Paris Agreement into account, industry is not set up to reach that ambition. And what is important to see is that, in for instance, the scenario modeling of the IEA, in their clean technology scenario, it's very clear that we'll have to go beyond the measures that brought us to this point, and we'll basically have to embrace the full mix of solutions and technologies available to get us there. So go beyond energy efficiency, look at green thermal, look at CCUS, and see how all of these solutions can play a role. Now, for industry, it's obviously there are a bit of challenges related to really reducing emissions, and We can basically sum them up in three things. First of all, some sectors just have inherent process emissions. You see there are some graphs, cement 60%, lime industry, aluminum, certain chemical sectors as well. So obviously, there are certain parts of the industry that need different solutions to decarbonize, and there, in essence, what we have to move to are solutions that create circular carbon loops and that basically find a good use or a good storage of these inherent process emissions. And so circular carbon will be a key solution to look at in the coming 10 years. Secondly, there's obviously the heat requirements. A lot of processes will require high-grade heat, like more than 400, more than 1,000 degrees. You see there a graph that clearly shows that the total energy consumed in these high-grade processes are a really major contributor. And the reality is that a lot of the technologies, the green technologies that are in the pipeline simply will not reach these high-grade temperatures. If you look at industrial heat pumps, you probably can crank it up to 200 degrees. Same with geothermal, probably 300 to 350. So it means that you need, in the end, green fuels. You need molecules that you can still burn in your kilns and your ovens, etc. So there, clearly need to make a shift to be able to create that green fuel portfolio. And lastly, and that's a major element, of course, in industry, is that you see there a graph, again, from the International Energy Agency that shows us actually all of the emissions that are locked in current assets. So they just did analysis on what is the remaining asset lifetime of in different sectors. And you see that actually industry is not moving a lot. So a lot of the existing installations, the existing assets, will lock in quite substantial emissions for the coming decades to come. And that means that we will have to find a solution where basically we need to respect that asset reality, because there's also economics that you have to respect. And so it means that we have to work with the existing assets and again, look at options to either move to green feedstocks or again, find solutions around circular carbon. And so that's the reason why we picked these solutions as a bit the focus of this presentation. It's stepping a bit beyond the available technologies today, and my presentation will really focus on how can we scale up green fuels, green feedstock, and circular carbon in the coming decades. And so in essence, there are four domains I will discuss with you. First of all, there's a question of, okay, what's a realistic cost down path of some of these technologies, and how, as an industrial company, can you really weigh in to make sure that you get a least cost pathway? So that's one. Second is we look at some cases of actually new forms of collaboration that are emerging around indeed this topic of green fuels and feedstocks, and see what that can mean for you as an opportunity. The third one is indeed looking at your asset strategy, and there come with some examples of how you can basically adapt your asset strategy to make sure that you can evolve your existing asset base according to your pathway. And then lastly, obviously, a major question is how can you make sure all of this gets funded? Let us start with the cost topic. So there, the major first recommendation is that the things that you should be looking at today is really have a very good insight into the cost dynamics of some of these new technologies. If you look 10 years back, then we basically have to admit that we have been systematically wrong on assessing the cost, for instance, of renewables. And we've always overestimated the cost and underestimated the adoption rate of renewables. And there's a risk that we will do that again with some of these new technologies. The problem here for you as industrials, the value at stake is a bit higher, because if you make wrong bets in the coming 10 years, it could potentially also start to impact your competitive position, and where with renewable electricity that was perhaps a bit less the case. But if you kind of miss the opportunity on some of the green fuels and feedstocks, that will have a bigger competitive impact. And so I bring here the example of hydrogen. It's obviously a topic of much debate and even a bit hyped. But I just want to give you a bit of visibility on some of the specifics of hydrogen as an illustration of how important it is to really understand the cost dynamics. And it all starts obviously first with the question of capex. We talk about new infrastructure, new installations. And there you see that in terms of the estimated capex cost of electrolyzers, the coming 10 years they will move a lot. Today already there's an estimate that Chinese-based alkaline electrolyzers are actually at the cost ratio of a tenth of what we are today in Europe. But it's clear that also Europe is on a path to drastically reduce the capex of these electrolyzer installations. That's due to efficiencies and productivity increase in manufacturing, of better purchasing of raw materials, but also simply of starting to deploy larger scale electrolyzers, and also finding a more modular approach to put these installations in place. So expectation vary a bit for the coming years, but it's likely that actually the costs will go down much quicker than what we anticipate today. Now that's the question on capex, but what's interesting about electrolyzers and hydrogen in general is that the costs of hydrogen is much more sensitive to the OPEX of the renewable electricity that is used to produce green hydrogen. And there you see in the middle curve, you basically see that sensitivity. At the bottom you have the levelized cost of electricity based on renewables. Then on the y-axis you have the levelized cost of hydrogen. You basically see that these two graphs for 2030 and 2050, where you have very different capex costs of electrolyzers, in the end do not make a big difference of your actual hydrogen price. A much more important factor is what is your cost of renewable. And there, obviously, in the coming decades, there's still expectations that renewables will continue to drop, and there will be important questions of what infrastructure do we build in areas that have an opportunity of very low cost renewables, and what are the supply chains that will emerge on that basis. But it's clear that if we can fix some of the renewable electricity questions, then we'll get a better outlook on hydrogen costs that are getting into the right range. And then lastly, and that's specific about this technology of green hydrogen, is that obviously as renewables continue to expand and more renewables are integrated on the grid, you will have a higher degree of curtailment, simply because supply is surpassing demand and there's insufficient storage, or you have grid congestion issues. Several reasons for curtailment, but it's a reality already today, and it's also expected to increase. And that's where technology like electrolyzers are really interesting, because what you see in that graph there, and let's take the blue lines of alkaline, if you have indeed moments where you have access to zero cost electricity, at these times, if you can run your electrolyzer to a certain degree of utilization on that zero cost electricity, you can already expect to dip below the famous $1 per kilogram for green hydrogen. And that shows the importance of also taking really an integrated perspective on that green hydrogen supply chain, and basically look for ways for you as industrials to really get access to these cost dynamics, because it's really critical that in the coming decade we find a way to get as close as possible to that $1 per kilogram. This is now just an example on hydrogen, but you see the same dynamics happening on some of the CCU technologies. So it's just important for industrials to get a very good visibility on what these cost dynamics are. Obviously, then the question is, okay, if you translate it then to your final products, when does it become interesting to start adopting some of these technologies? And I took here two examples. One on the left is basically the levelized cost of steel, where we compare on the one hand green hydrogen based produced steel versus the traditional coal-based blast furnace production routes. And there you see that indeed what we can expect is that by 2030 the green hydrogen based route starts to become competitive with, let's say, higher expensive coal production routes. So it also means that as soon as CO2 price will kick in and we get, for instance, to 85 euros per ton, which will not be very soon, but might also happen around 2030 perhaps. You see that actually the green hydrogen pathway already becomes competitive with the traditional one. Same on ammonia. I'll not go into specifics, but there as well, you see if you compare a hydrogen-based ammonia production with the classical natural gas-based one, but with CCUS technology on top, you also see that basically by 2030, you already get into the territory where some of these applications are competitive. And that's important because that means 2030, looking at your investment cycle, looking at also the technology adoption that you need to do to get to that point, it basically means that you have to start today. Another key element, obviously, is finding ways to mutualize some of these costs. And I took here one example, a concrete project we're working on the Port of Ghent, where actually the Port of Ghent has been facilitating some of the major industrial stakeholders in the port, together with the gas transmission system operator, Fluxys, to basically build a CCU hub and backbone. And that's obviously a key enabler for multiple players to tap into to get access to CCU applications, either as a provider of a CO2 stream or an off-taker of a CCU-based product. In this case, for instance, as Engie, we will build an electrolyzer, starting with a 60 megawatt electrolyzer, to produce basically methanol, green methanol, but with a plan to really scale it up to almost 500 megawatts after 2030, and basically also in this way, kind of scaling up that backbone, that CCU hub, to something that could eventually serve more than 500 companies in the port area. And so this is important for you, as an industrial. If you have some of these applications or you have some of these opportunities, is to connect well with some of your peers and really understand what's also happening in terms of some of this shared infrastructure. On the collaboration, so there are two examples. One is again, as an industrial, is to really get a good sense of what are some of the synergies you can also realize with some other industrial players around your site. And there we see very good momentum today. Again, here an example from a port area, Port of Antwerp, where again we are supporting a power to methanol project, but where you see that the overall vision that's driving this and synergies are very elaborate. So there's an offtake of methanol by Innovin. What we're also doing in the process is look at hydrogen applications based on the electrolyzer, both towards, for instance, cold ironing solutions for ships, towards mobility within the ports, and even as providing green hydrogen feedstock to two other industrial players. So that is a really an excellent example where, as you start to shape your decarbonization pathways, really as an industrial, have a look of what is that collaboration potential, what are some of the dots you can literally connect with some of neighboring companies, and in that process, really try to mutualize and jointly invest in some of these new technologies. It definitely de-risks a lot of that journey. Another key one for US industrials to think about is that obviously the future infrastructure and the future needs, energy needs, will also start to converge more and more the world of let's say energy actors and industrials. One example here is for a lime producer that has a lot of inherent process emissions. And so where we as Engie are actually building the electrolyzers, where we are as well building a methanation installation, and in essence provide that lime producer with a supply contract of e-methane, so synthetic methane, based on their CO2 flow and our produced green hydrogen. So it's a setup where we as Engie basically assume a lot of the operational risk and also financial risk of such a project, and basically in that sense drastically de-risk that decarbonization journey for that lime producer. And this is now a momentum, a change, an evolution we see happening with a lot of industrial players, and it's really something to clearly think about is what is kind of the contracting models, what are some of the future partnerships that you will need to basically realize all of the investments you need to move to some of these green technologies. Moving on to your asset strategy, I think one critical point, given that lock-in that I was talking about, is that you should reflect on how can you create a dual asset strategy. And there's a very good example here of ArcelorMittal that just published as well their climate action plan, so it's accessible for all of you. But of course, the steel industry has, especially in Europe, has traditionally been based on blast furnace, and these are assets, long-lived assets, more than 40 years. So you need to find solutions on the basis of that existing asset base. And so what ArcelorMittal has done is they start already exploring the past 5 years a lot of the new technologies around CCU, around biomass, on pyrolysis, etc., to basically replace coal by alternatives. They're also looking at using hydrogen directly in the blast furnace to replace some of the pulverized coal. But in essence, they created a whole smart carbon production route that for them is a critical piece to enable the transition on their existing asset base. It has some advantages in the sense that it's also creating a couple of byproducts, and the slag can be a good alternative to cement. They will also produce significant amounts of bioethanol, which can basically be a feedstock to chemicals. And so they calculated that in essence, this is for them the cheapest production route, but not necessarily the one that is the most logical or the most sustainable, because you still have a lot of CO2 emissions that you have to capture and basically either store or convert. So they define this, let's say that pathway next to what is called DRI. So DRI is direct reduced iron, just means that you use hydrogen as a reductant instead of natural gas. And so there you can easily, as long as you have a DRI asset, you can fully decarbonize the inherent production methods. But what they find out is that it's probably impossible to scale up sufficient green hydrogen supply before 2030. So what they basically do is they invest in the coming 10 years a lot in the smart carbon route to hit their 2030 targets, and at the same time, when in their asset plan or their footprint strategy, they have a chance to replace blast furnace by DRI, they will do so. But this will take much more time. And so it's kind of a dual speed asset strategy, which shows for me as a good, let's say, archetype and kind of a good illustration of what a lot of the industrial companies should do in terms of considering how, on the one hand, they can build on their existing asset base a clean pathway, and at the same time create a whole new clean pathway for all new assets to be built. There's a second important element about your asset strategy, and that's really, when you reflect on that, is to design for modularity and flexibility. Why? Again, you want to make that transition as smooth as possible. And so here one illustration, and that's based on a conversation we're having with a steelmaker in Australia, is that we help them find a design that makes that transition much smoother. And what you see there on the left-hand side is that's what I just described. So that DRI process, where basically renewables will be turned into green hydrogen through electrolysis, which then feeds a direct reduced iron kind of production methods. That's, let's say, is the standard technology setup that most steel makers are looking at to fully decarbonize. But what we introduced was the notion of, okay, do not feed directly the hydrogen into your DRI system, but basically include a methanation step. So what we say is that you can still use your DRI installation on the base of natural gas, so continue to do that. We will tap into the flue gas of the DRI installation, and with the calcium loop, basically make sure that we can capture the CO2 and combined with the green hydrogen, actually make e-methane, so synthetic methane, which you can perfectly blend with the methane that's coming from the natural gas grid. So the obvious benefits of this scheme is that, first of all, there's no need to change the existing DRI installation. It continues to run on natural gas, so that's already a transition cost that is reduced. Secondly, this setup basically offers you full flexibility to modulate your synthetic methane input between 0 and 100%. And that's obviously giving you a lot of benefits of more gradually ramping up your transition. There's also no need for buffering or storing green hydrogen, because obviously renewables are intermittent, so you have to produce when you have it, and storage of hydrogen is technically is challenging and not cheap. And then lastly, and most importantly, is the electrolysis and methanation step you can build up very gradually in a very modular approach. So you can easily, spread that whole investment over a couple of years and more gradually overturn your asset base to even in the end 100% synthetic methane based. And that's a clear example where it's important to reflect well on your asset strategy, the type of solution you go for, and really maximize that modularity and flexibility. Last thing is on obviously bridging the funding gap, where first of all, there's a question on for your initial steps that you want to take on some of these technologies. What are some of the funds you can tap into? I'm not going to go too much in detail here because I think it's well known by this audience, but obviously there's the ETS Innovation Fund, where if you're not applying yet, the closure of the first call now of 2020 is end October, but that's a clear one that can provide you a lot of funding to really move pilot projects to more industrial scale. There's as part of the European Green Deal now a first call launched under Horizon Europe with a deadline of end of January, where there's actually around 11 area topics, a lot of potential for industrials to also look at circular carbon, at clean energy. So definitely an area to look into. And then lastly, as part of the recovery package, there's also an expectation, still to be clarified, that through the member states, a lot of the more than 600 billion will also flow to green transition related projects, and that the industry will also be able to benefit from that. But then next to the funding for some of your pilot projects, there's obviously the question on what about the longer term, and what about the business model, the business case, how to make it work. I think there are important three elements on which you need to anticipate. First of all, obviously, I form an opinion on what you believe will be the carbon price trajectory in Europe. There will be changes to the ETS. There might be other measures taken. There's even member states like Germany claiming that the carbon price will soon be 50, and then they're assuming even beyond 2030, moving higher up to potentially even 80. There's obviously as well the carbon border adjustment mechanism, which is now under discussion, will be announced normally by mid-2021, where actually will be very important to create the level playing field in Europe and basically avoid carbon leakage. On market development, there's the big question for you as industrials. Okay, first of all, how will procurement standards and criteria evolve of your customers, but also of public procurement? What can you do with some of your key customers to make sure you have agreements and a bit of guarantees that they have an offtake of some of your green products? And then importantly is more on the let's say the market developments, is making sure that there's eco-label certification, really initiatives from you as industrials to recognize green products, and basically also pave the way to then start to charge price premiums. And we can also, I hopefully still expect from policy perspective that there's also perhaps feed-in tariffs or contracts for difference for some of these green products like green steel or others, where you see some initiative from the EU as well. And then lastly, it's also important, I think, from a strategic perspective, that you anticipate how some of the value chains might change and then some of the profit pools. There's obviously the big question of, and that's partly COVID induced, but I think partly a phenomenon that is already ongoing, is the question of reshoring, and that will be accelerated as well by the carbon border adjustment mechanism. You also need to take a life cycle approach to really see from a circular perspective what is some of the value you're creating for your customers, and how can you really tap into that to also increase their willingness to pay. And then lastly, that's also a policy front, is also to advocate for a better integrated energy and materials policy, so that it's easier for sectors to make the connects and basically get rewarded for providing the feedstocks of tomorrow. So these three elements as part of your strategy and your long-term business case planning are really important to take along. So all in all, just to conclude, so really for industrials, we believe the coming decade is the one that matters. It's called the climate decade for a reason. It's where you really will have to start to explore all options. And so we truly believe that we're now at the start of a big momentum building up on green fuels, feedstocks, and circular carbon. And our recommendation is really, okay, anticipate, have a long-term perspective, really start to engage within your company, but also with potential partners. And in the essence, I think is really collaboration will be key to really get to a economically sound and competitive decarbonization pathway. Let us open the floor to questions.
Thank you, Ben, for your presentation and your outlook on the green fuel future. Are there any questions in the room or from the digital attendees that we should answer right now? We have a question from Paul van Son.
Thank you, Ben. This was a really great presentation and very comprehensive. And we also see how fast now many new elements are getting into this whole complex of energy and industrial use and everything. And I very much like also your funding or the kind of incentives that you need to start up these new markets. I may point maybe at one thing. I didn't see it in your presentation. Maybe you had it there or I missed it. That is to accelerate remote markets, like in the deserts, where hydrogen will be produced at one time at very low cost. To start with asset swaps or commodity swaps through a green system. Because at the very beginning, the transport of these new commodities like hydrogen or ammonia would be difficult. And to just start first with the production and the local consumption, a good kick off or start would be through certificates that would then provide industries in Europe first start with a green commodity, but then green commodity which still rests in the local, regional, remote markets. So that's maybe something you could take on board in your operation.
That's a very, very good point. I think there's obviously a big question on first of all, if you look at the scale of the future energy system we need, it's very clear that we will not be able to realize that just within Europe, even if we find a way to scale up offshore wind and tap into all of the solar potential more in the south, etc. I mean, it's not sufficient. So there will be definitely a component of imports and production outside of Europe. But you see that Europe is definitely welcoming that as part of the current Green Deal call. There's a whole chapter on basically scaling up renewable production in the full Mediterranean, so including North African countries. So they do anticipate that we will see future supply chains coming from this part of the world. And it's definitely also when I talk to the industrials and I look at some of the coalitions that are forming, it's certainly a viable route that's being discussed. To your point, that can definitely be supported as well with the right policy instruments and market mechanisms to indeed facilitate the investments in such remote assets. And there, yeah, I think there's still to be seen what will eventually be created. But it's clear that a strong policy push on that front could be very beneficial as well.
Yeah, and I'm very happy that you point at the Green Deal, in which our proposal of this 2 times 40 gigawatts North Africa, Europe has been included, which is a great step also to get the synergies between continents, which will be very, very important for the next generation of an energy system.
Absolutely. Absolutely.
All right. Any further questions in the room?